Okay. Luckily, this confusion about fxy and fyx, right, has a nice, easy solution most of the time. So there's this little theorem that tells you if fx and fy are continuous, if x, y, so if fxy and fyx are continuous at some point a, b, inside their domain, then fxy at ab is the same thing as fyx at ab. So there's one confusing thing in here. What's the confusing thing in here?
Inside their domains.
Yeah, that inside their domains bit is just a titch subtle. Okay? So the thing I want you to think is like, here's their domain. Right? That point AB needs to be well inside there, meaning it can't be on the edge.
Do you mean like the very edge? Or just near the edge?
So I mean it can't be on the very edge.
Like on the border.
Yeah, it can be near the edge as long as it's not actually on the edge.
Because on the edge you could still be in the domain, but any movement you'd be out. You can't be there.
Yeah, exactly. So I need a little bit of cushion, right? So maybe we'd think, okay, as long as there's some little open bit around this thing that's all still in there, I'm okay. But if it's actually out here on the edge, this would be a problem. You guys see that? Establishing whether or not something is on the edge of a domain or on the interior of a domain is a little bit hard. It's a lot easier if I just notice, like, if fxy and fyx are continuous everywhere, right, then there's no problems here at all.
But if you end up with weird, like, over X stuff.
Yeah, if I had problems with domains, right, like over x's and jazz with y's, then I might need to consider this carefully. Cool. In practice, this is true basically all the time. But I want you to be aware that there's this little problem that sometimes these two things aren't the same. That doesn't come up often in engineering, but if you're a mathematician, this might be a big deal. Cool?